This video is brought to you by Sporlan. Quality, integrity, and tradition.
So this is a Sunday morning service call at a local sports bar. Their banquet room, the air conditioner is not working. When I went in there, it feels like it's 90 degrees in that room. The thermostat is interesting because the thermostat says 73 degrees, but I come up onto the roof and the unit is not running at all. No condenser fan motors, and what's even more alarming is no safety alarms. This is a York Predator unit. If you know how these work, you look up in that top left corner, and if there's a safety limit that the board has stopped the unit on, it'll flash red and then blink so many times to tell you what the error code is. You can usually look down here. Right down here it tells you the flash codes, all that stuff. But regardless, we're not getting a flash code. So the first thing that we're gonna do is we're gonna check 24 volts to the board to see if we're getting a 24 volt call. The thermostat was indicating that it was calling for cooling. So that's what we're gonna check. Okay, so what we're gonna do here is set my meter up right here so we can see it. Okay, and I'm gonna go up here to the board and I'm gonna jump from C, which is a little difficult to see, which is common, to R. And we get 24 volts, C to R. Okay, that's good. Now I'm gonna jump over to C to G. We get 24 volts or 22 volts, okay? And now I'm gonna jump over from C to Y1 and we get nothing, and I'm gonna jump from C to Y2, we get nothing. So according to this board, the thermostat is not calling. So that's interesting. Now another thing that I will point out, and we will correct before we leave, is my transformer is tapped for 230 volts. I do not think that we have 230 volts coming to this transformer. Here in Southern California, it's pretty typical. If you've got a restaurant, you're gonna have 208 volts coming to the unit. We tend to see that in shopping malls. You'll see 240 volts, or you'll see 240 volts in residential neighborhoods where there's like a gas station or something like that. That's just something common to my area. That does not mean that's going to be the same way for the rest of the country. Okay, so it's just very uncommon for me to see a 230 volt supply going to a unit in my area, so that just catch me off guard. So before I leave, I will correct that. That's an installer issue. Funny thing is they haven't ran into a problem, and this unit's probably 12 years old, so go figure. But they must not. Where you really start to see that becoming a problem is when you have low voltage, which where I'm at right now, this is out in the Coachella Valley. We don't have low voltage problems in this area, but when we head more inland to where my shop is at in the Inland Empire of California, we have a lot of low voltage problems where in the summertime the voltage will drop down to 180, 190 volts, and that's when the incorrectly tapped transformers will really stand out, because when you've got 180 or 190 volts coming to the building and you're tapped for 230, that transformer more than likely is only going to be putting out 16 to 17 volts, and then you'll see issues with, you know, contactors not pulling in and whatnot. So okay, so at this point I do not have 24 volts coming up here, so it's looking like it's a thermostat problem in all actuality. So what I'm going to do is I'm going to kind of look, I think this is the thermostat mess right here. I'm going to look into where the thermostat wires are coming from, and we're going to make sure that we're not losing voltage anywhere. So here's my thermostat. It's not loose from the wall. Everything's good. Yeah, that's interesting. It looked like it might be a bad thermostat. I'm gonna go make sure there's no twist timers that are in line with. So there's some interesting stuff going on here. Let's see if I can show you guys. This is very peculiar. So when I check from common to R, first off I retap that transformer. So now you notice we're getting actual 26 volts instead of like 21, 22 volts, okay? So that's the difference too. So I tapped the transformer to the 208 volts. I just moved the tap over, okay? And we're getting better control voltage. Okay, so this is R to C, all right? Now, I'm gonna go C to Y1, and I get nothing, and I'm gonna go C to Y2 and I get nothing. Okay? Now watch this. If I disconnect Y1 and Y2 and I go from C or common to Y1, I get voltage. And the same thing to Y2. I get voltage. So something is robbing the voltage. So the thermostat is working from the looks of it. But when it goes into the board, it gets lost. So it's very interesting. It could be something robbing the voltage, meaning a contactor coil that's bad or something like that, or a board that's bad. Or it could be a bad thermostat too that's not making a good switch. It's looking like a bad thermostat because what I did was I jumpered from R to Y1 directly, and I got my delay light coming on. So it's gonna call right now. See, it just turned on. So it's almost like the thermostat isn't making a good switch, and it's just not sending enough voltage up, like it's a bad contact in the thermostat. Because when I jump it out, it runs. So, yeah. And it's either way, Y1 or Y2. So it's gonna be a bad thermostat. So you guys understanding what I'm doing there? So when I had the thermostat wire hooked up to the board, let me go ahead and disconnect this. When I had the thermostat wire hooked up to the board and I tested from common to Y1, I got nothing, and common to Y2, I got nothing. But if I disconnected the wires, Y1 and Y2, and I tested from common to Y1, I got 22 volts. Common to Y2, I got 22 volts. But it wouldn't pull in anything on the board. When I took a jumper and went directly from R to Y1 on the board, it immediately turned on. So that tells me that we were sending power downstairs, but we're not getting a good connection at the thermostat coming back upstairs. Talk about confusing. So I diagnosed it as a bad thermostat. And it still is a bad thermostat, but look at what I found. I disconnected power so that I could change the thermostat, and I jumped out the unit. But you notice how this one that's labeled AC6 turned off, and this one that's labeled AC3 is on? So see, someone has mislabeled these thermostats. They're not labeled correctly. So we still have a bad thermostat, which is this one, but it's mislabeled. Alright, so we've got the thermostat changed out. Set it up, automatically turn on and off. So we're good to go. So the whole time I was changing the thermostat, I had this unit jumped out so it was running, and it cooled down that room really well. So now I came back up, and mind you, what I did was I disconnected all the control voltage, this control wire, so that way I could change the thermostat without worrying about tripping out a transformer. And right where the control voltage connects up on that terminal board, I had jumper wires. Just, you know, thermostat wires jumping from R to G to Y1 to Y2, so that way all stages were running. It was cooling down that room, and then that way I could do the thermostat, change the sensor, get all that stuff, and program it while the unit was cooling, you know, to get the room down to temp. It's currently about 100 and I don't have my thermometer out here, but it's probably about 108, 107, and it's probably about, I'd say 50-55% relative humidity right now. It's pretty warm out here, pretty humid, so I wanted to cool that room down so I didn't have to wait too long. So, like I showed you guys in the video, thermostat was mislabeled. I'll get into something in the recap too that led to. But for now, I just went ahead and connected the thermostat back in. I'm gonna watch this unit operate, make sure it turns all stages back on. It's currently in the delay mode. So it'll be a second and then it'll turn on, and then we'll go from there. So I've just been letting the unit run for about, I don't know, half hour now, just letting it cool down the room in there. And I just went to go check delta T across the coils, and this is what I come up with, and this is rather alarming. I've got a 96-degree return air and a 60-degree supply air.
All right, so I had some more footage, but actually my camera overheated and cut out. It does that when it gets above 100 degrees. We tend to have problems with the camera doing that. But anyways, so initially, we had a service call on their banquet room not working, okay? So when I arrived, the banquet room was damn near 100 degrees. And mind you, it's part of the same building, okay? It has open doors, but it was still like 100 degrees in that room, which was trippy. Found that the unit had a call. Well, it didn't have, yeah, it was acting like it had a call for cooling, because when I pulled the wires off, we had 24 volts, but when I put them back on, it wouldn't engage anything. Okay, so there was something going on there. That led me downstairs to look at the thermostat, and I diagnosed a bad thermostat because the thermostat indicated that it was calling for cooling. When I went to go replace the thermostat, that's when I realized that they had them mislabeled. Okay. And this actually, what I kind of alluded to in the thing was it opened up another thing, and it totally makes sense now too. Previously, we had a service call where we had, and I hadn't changed it yet at the time of this filming, we had diagnosed a bad zone sensor for another thermostat. Well, come to find out, they had several thermostats that were mislabeled. Okay, so I ended up going back out there. So let me finish up the video. Okay, so went ahead and changed the thermostat, and then the unit was working fine. Changed the correct thermostat, but then I found that we had a 96-degree return air temp. That was where the camera cut off. What was actually happening was the economizer damper has a minimum outside air position, and the minimum outside air position was doing what it was supposed to be doing. It opens the dampers like 10%, 12%, whatever it is, and allows for the minimum outside air for fresh air requirements for the building. Okay. Well, because it was doing that, and the unit had a call for fan, the indoor fan, because it was in an occupied mode, that's the way it's set up, we were blowing in 110-degree air into that room. And that's why it was over 100 degrees when I got there. Okay, so they just weren't getting a call for cooling, so the compressors weren't turning on. This just shows you, why, and unfortunately we don't do it enough, but why we need to temper our makeup air for our buildings. Meaning that we need to condition, whether it be cool or heat, our makeup air. Here in Southern California, it's very, very common for us to use the RTU units, or the air conditioning package units, minimum outside air positions on the economizers as our fresh air for the building. Now, this restaurant does have a makeup air unit too, okay, but they are using some outside air from the air conditioning units, or the RTU units also. And so this is a great example to show you how hard that unit is working when it's just trying to cool the building, when there's customers in there, because it's still trying to cool that minimum outside air that it's bringing in too. So it's really working overdrive, especially when we get above 100 degrees. So anyways, so what I was alluding to a minute ago was we also found I had previously diagnosed a bad zone sensor for another thermostat. Well, come to find out, they had several thermostats that were mislabeled. I ended up going back out. This was a Sunday that I filmed this video. I ended up going back out the next week, took another service technician out with me, and we went through every thermostat and relabeled them, and actually didn't need to change the zone sensor after all, because once we figured out that all the thermostats were mislabeled, we got them all dialed back in. And, this kind of stuff happens. You really have to pay attention before you start diving into things and verifying. And luckily, these are the Venstar thermostats. They lose power when you de-energize the unit. Most thermostats don't. If you do like a Honeywell, the one that I put in, the Vision Pro or 8000, whatever it is, it has a battery backup, so it doesn't lose power. So on some of these Venstar ones, which I don't care for the Venstar thermostats, but that's one cool feature about them is if you want to know which AC is which, just go shut it off and the thermostat will go blank. So I really appreciate you guys taking the time to watch this video. I know there was a few things in the video. I realized as I was watching it, I didn't show the thermostat that it ended up being. I didn't show that it was actually calling, but it even on that thermostat, it was doing the same thing. It was showing that it was calling for cooling, and we weren't getting anything. Okay. But anyways, I really appreciate you guys taking the time to watch these videos. Leave me some feedback down in the comments. Send me an email to hvacrvideos@gmail.com. And pay attention. I do live streams every Monday, typically, so long as there's no problems with work, at 5 p.m. Pacific time. And I usually answer all the questions that you guys send me. I try to pick out some good ones, more common questions that I think everybody will benefit from. And I try to answer those live on the live stream. So feel free to shoot me a question, and I'll definitely answer it. And if you want me to mention your name, who you are, when you send me a question, tell me in the email or the comment. Just say, hey, mention my name, I'm whatever, and I'll give you guys a shout out too. So, all right, really appreciate it, and we will see you guys on the next one.